Hi all, we're going to get started in just a minute. Got some issues with our slides. All right, hello. Welcome all, and thank you for a wonderful UIUCTF 2024. Um, I'm going to confirm someone can hear my audio before we continue. Otherwise, that would kind of defeat the point. Any day now. All right, great. I'm going to go ahead and get started. So first of all, I would like to send a huge shout out to all of the sponsors that make UIUCTF 2024 possible. So CrowdStrike, Trail of Bits, Zelic, Batel, Red Lattice, and our cloud infrastructure sponsored by Google Cloud CTF sponsorship. Huge shout out and thank you to all of our sponsors. Without them, UIUCTF would not be possible. So thank you. A few statistics. So this year we had 959 teams participate, which is, I believe, approximately 100 teams or maybe 99 teams more than the 861 we had last year. We had a total of 1,221,956 total passengers served. As a reminder, the number of passengers you served corresponds to points on RCTF. 363 mod mail tickets resolved, and 42 fake feedback flags submitted. We do see you. Nice try. um, and I would like to congratulate the top three winners of UIUCTF 2024. Without further ado, we have the Hackers Crew, Rekka Pig, and organizers. Thank you so much. We really enjoyed writing these challenges. Um, yeah, yeah. And then we also have runner-ups. So congratulations to Team Austria, Class Gang, uh, BKISC, Leak, Matter Hacks, SNHT, and Cyberspace for places 4 through 10. And again, huge congratulations. Thank you for participating and making this being the impetus for this event. All right, so and I forgot one more thing. We're going to discuss this a little bit later. The challenge author of Pofy, but we'd like to mention that Maple Bacon got a compression score of 1337 on Pofy, which was really crazy. It actually got a little bit higher than this, but of course, the elite numbers. So again, congratulations to Maple Bacon. We're really looking forward to the blog post on how that was achieved. Write-ups. So this year we have over $1,500 in the Writeup prize pool. So the top three write-ups will receive $150, $125, and $100 respectively. The remaining prize pool will be used to award quality write-ups with about $20 to $100 per challenge. So you can win multiple write-up prizes, but there's a maximum of $200 per individual. And write-ups are going to be graded based on per individual challenges or challenge suites. So there are, I believe, 3 challenge suites. There are 2 OSINT challenge suites, and Pony Pass and Pony Pass 2 is a challenge suite. To clarify, syscalls and syscalls 2 is not a challenge suite. So you could submit write-ups for syscalls and syscalls 2 individually. The syscalls 2 is kind of nominally about syscalls. It really has nothing to do with the first syscalls challenge. So yeah, when you're creating write-ups, prioritize quality of the write-ups over quantity. The challenge authors and other people involved in UIUCTF will be voting on which write-ups should receive prize money. So again, we're really looking forward to seeing quality write-ups that hopefully can help other people learn about CTF and about specific challenges. So we're looking forward to that. Yeah, and then again, some follow-ups. Just this VOD will be posted afterwards, and also probably the slides. So if you have any questions about write-ups, feel free to ask in the UIUCTF 2024 Discord. But again, if you want to make write-ups private, make sure that we, the challenge authors, have access to that. Otherwise, we can't read it and we can't award you anything. And again, use LLMs, but don't use other people's stuff. Okay, and in order to expedite the process of write-ups, we're going to be inviting some of the challenge authors to the stage to go over. Oh, hold on. I'm supposed to look off into the sunset every so often, but I end up not doing that. Okay. We're going to be inviting challenge authors onto the stage to discuss some of their write-up solutions, and we aim to have one in each category. So first up, I'm going to invite Yifei, the author of Syscalls 2, to discuss his challenge.
Hi. Does the audio work? Okay. So it's IOU ring. That's an intended software. Is IOU ring. So IOU ring has its own FD table. Like it's called the fixed FDs, and then you can set up IOU ring to use that thing instead of the per process file descriptor table, which doesn't bypasses all the checks. But the problem, I initially thought was, doesn't IOU ring, the setup of the IOU ring itself needs an FD? No, it does not, because, IOU ring setup register FD only, IOU ring has something called a register ring, where, it keeps it, they can do a bunch of symbolic links and then just get it to work. So request key is a sort of like geo escape that I kind of had from last year's challenge, and they just remembered and then got this to work. I saw another challenge that symbolic linked in int to create, and that also happened to work. The other unintended that I first knew was kexec mode from Writeup. I don't know how to pronounce his name. So kexec mode actually takes a buffer instead of a file descriptor or any files names or something. So you can actually just load your own kernel and profit. And I heard that from Team Australia, was it? They did kexec mode to to their own memory scanner. So the exact memory scanner that scans the entire physical memory range for the flag. And yeah, but like I really wanted to like release a fix, but yeah, they so like it was already sub-intended, and the unintended are still kind of creative, like pretty creative ways to solve it. So like in the end, just and then the flag leaked the intended solution. So yeah, didn't release a fix. That's all.
Great. Thank you, Yifei. And again, if you have any more questions, feel free to ask in the general channel or in the Pwn feedback channel for Pwn challenges. All right, next up, we will be discussing OSINT New Dallas. And unfortunately, the author is in China and is asleep right now. So I will be playing back a pre-recorded video. Yeah.
Hi, I'm the author of New Dallas, and I'll give you guys a brief walkthrough of my approach to this challenge and certain methodologies that I will use to, solve the challenge. Now, you're given, actually, this is kind of a hint already because I said super wide roads with trains. You're going to find the intersection between the rail and the road. New Dallas is kind of a meme that I just made up because Texas really likes its wide road infrastructure, and it has actually no relevance to this challenge. So I just opened it in my Google Maps, and here is the image. So you can see that it is a 4-lane road, and or actually an 8-lane with 2 shoulders, whatever. So one side is 4-lane. I'll just refer to it as 4-lane. This is actually very important because you don't see a lot of these in the area, which I'll get to later. This is an elevated path, so this gives you some sort of an interstate vibe instead of just beneath the ground. Not beneath the ground, on the ground. This is kind of an off-ramp, and there are these trains. Now, the livery, the details are also very important. You can see the green roof, the glass, whatever, and there are 6 of them. There are 6 carriages in total. So we'll get to that later as well. So first thing that I believe any sensible person would do is to Google reverse search it. Why have I not downloaded? Oh damn, dude. Okay, there we go. There we go. So we got a Volkswagen Passat, but you can kind of see that this is a China specific, or at least it's made in China. Focus on the train. What does it say? Oh, it says somewhere maybe in Japan, maybe in China, Shanghai, line 16, monorail, doesn't matter. So it's some sort of a train, something. Right, and if we search the entire image, of course, these people exist, I'm not going to say much about them, but they exist. You can kind of see, oh, something expressway. All of these are Chinese expressways, you can see. So you're like, oh, this something China, right? It's related to China, probably. And if you're still not sure, you can look at the license plate. This is definitely not an alphanumeric character. This license plate is like a bluish license plate, and you can just look up which country has blue passenger license plate. And you can obviously see, right? So that's that. So you're like, oh, great, that's China. So what is this exactly? This is some sort of a train, is whatever. We can just look at this, right? Rail transportation in China. And you're like, wait a minute, these are white, these are mostly white. And look at this nose, it's long, it's high-speed railway. If we look at other models, this is also long, this is not this is very short nose. a very, very short nose, and this is also 6 characters long. There's no way it's a train. So this is a subway system of some kind. And then you're like, wait, so I can just be like metro systems in China. Holy shit, there are so many cities. What do we do with them? This is also very simple. As I said, notice the details. This is a 6-car system, and this is an elevated path. So let's just say, oh, we have so many lines, so many things. You know, let's just go down a bit, go to specific cities. There are so many lines, we go to specific cities, right? And we click on one of them. Let's just say this one that kind of looks the same, greenish color or whatever. Underground. Oops, that's not our thing. So this is actually very easy to filter. You don't really have to click through all of them, right? And I don't expect you to. Oh, this says underground elevated. That's possible. This just completely doesn't match. Look, these windows are smaller. There is no blue strip on the top. Skip. It's not Hong Kong because the license plate is actually very different. Oh, what is this city? Underground elevated. Green thing. Green thing. Maybe this matches. We can put it on a wish list. Not wish list, like basically a candidate list if you hold one. Oh, 6-car. Underground. Completely underground. Not what we're looking for. Underground, not what we're looking for. It's really fast to filter through all of this. I think my point already stands. So to give you guys the answer is actually this line too. So you can see the color matches, these matches. You can go and match the details. Another crucial 6-car. Elevated. It's also a third rail system, meaning it gets power from this rail. So it doesn't have any overhead lines. And in some metro systems, many people thought it's Shanghai, but Shanghai's lines, some of them are not third rail, are overhead lines. You can see the overhead lines. This doesn't have an overhead line. It has nothing on top of it. This is also a very important factor. Right, okay, then you can just go to Google Maps, Google Maps, go to the city, turn on the overlay, turn on transit, and you're like, great, that's a green line. And then you're like, where's the road then? Right, where's the road then? I will actually just completely turn off label and let us focus on the expressways. This is only 3-lane, right? If we zoom in on other big road, this is also just 3-lane. This is elevated 3-lane. This is a bridge, so it doesn't count, but that's honestly 2 lanes, right? So just looking around, you don't see a lot of. That's also 3-lane with 3-lane with a shoulder. You don't see a lot of 4-lane roads, and there's a reason, because 4 lanes are kind of excessive in most cases. The reason this is a 4-lane is because it's G2, and G2 is one of the I won't say most important, but it's a very important expressway. That's why it's wide. It's very useful. So now you can just go to the intersection between G2 and your subway system, which is here. Now due to the coordinate drift, it is here. You can kind of see, okay, this is where the train is running, where the subway is running. This is 4 lanes with a shoulder and a ramp here, which matches with our image. And that's your solution.
All right, great. And next up, Nikhil will be sharing the solution for crypto groups. or maybe not.
All right. Is
Oh,
the audio working?
yeah.
Okay.
Go ahead.
Right. So groups, the point of the challenge is solve a discrete log problem modulo a large Carmichael number. So there's really two parts to this challenge. Part one is find a large Carmichael number. Part two is solve the discrete log problem. So for part two, you might think you want to use Polig-Hellman. That's pretty standard. If you do that, you want a smooth order for the group. So that's something to keep in mind even as you do part one. For part one, you can just sort of go on Google and Stack Exchange and look for how to generate Carmichael numbers. You'll probably find something that gives you this method. It's on the slide where if 6n plus 1, 12n plus 1, and 18n plus 1 are all prime, then their product is a Carmichael number. At this point, you want to think about how to use Polig-Hellman. The order of the multiplicative group modulo C is 6n times 12n times 18n, which is the totient of C. I think it is technically possible at this point to just plug this into a discrete log problem calculator if you use the right one. But if you sort of want to do this all from scratch, you will sort of need to re-implement part of Polig-Hellman because step one is to factor the order of the group. So you want a smooth order for the group. So you want n to be smooth. So you essentially generate smooth numbers of the right size till you get 6n plus 1, 12n plus 1, 18n plus 1 to all be primes. Primes are relative.
I think our
Can you hear
speaker,
me?
yeah, sorry, I think our speaker may have cut out. We will come back to this, but for the time being, I'm going to let Pete present on a few rev chals. Take it away, Pete. Oh, sorry, excuse me. But before that, I'm going to have Richard present on Picofy.
Well, can you hear me?
Yeah.
Okay, cool. So I wrote Picofy for UIUCTF 2024. This was a little bit different from the other challenges we had this year and in the past, in that we had a separate leaderboard for this challenge, which was a cause of many of our infra headaches. I'll leave it at that. So the gist of the challenge is you have to compress some sort of input, write it in PIC assembly. Of course, you can use the compiler and get that set up, but it's a very resource constrained system. And you want to write a pretty simple compressor that will fit in the constraints we've given you. Now, in terms of algorithms, there's a lot of literature online and elsewhere on different compression algorithms. You can do things like run length encoding. You can do bit packing. If you've noticed, the input data is only using, I think, the lowercase or uppercase letters and numbers. So you can actually pack each input byte into 6 bits. And that's what the baseline solution was, if you're curious. And a lot of teams improved on that, doing things like dictionaries. Other ideas are using lookup tables for like n grams, 2 grams, 3 grams of the characters. There's a lot of variety here, a lot of creativity. So it was exciting to see teams compete on this one.
Yeah,
That's all I
sorry,
have, George.
did you want to discuss the maple bacon solve or it's
Uh, I don't
okay if
think
not?
it's my place to talk about their solve. So if they, yeah, they did do a very good solve. They got the score of 1337, which was somewhat of a coincidence, but it was very legit solve. They want to discuss that or do a write-up of that. That's up to them.
All right, great. Thank you, Richard. We're gonna come back to crypto groups. Nikhil, I think you cut out about when you were discussing. I actually forget exactly where you cut out, but go ahead if you're still here.
Okay, can you hear me now?
Yes.
Okay. Right. So I think I'll just sort of summarize maybe the first half. You need to generate a large Carmichael number. You can look online for ways to do this. You will find the 6n plus 1, 12n plus 1, 18n plus 1 method, where if all three of those numbers are prime, their product is a Carmichael number. At this point, you want to figure out how to solve the discrete log problem modulo that Carmichael number. Simple brute force is probably not going to work, given that the Carmichael number is like 512 bits large, at least. So an idea is Polik-Hellman. If you sort of just plug this into a discrete log problem calculator that uses Polik-Hellman, it might be solvable in a few dozens of seconds or maybe a few minutes. You can do much faster than that. You know that Polik-Hellman is efficient if the order of the group is smooth. You know that since you already have a factorization for C, you know that the order of the multiplicative group is 6n times 12n times 18n. So if you generate n to be smooth, and all of those numbers, the 6n plus 1 and so on, are prime, you will have a smooth group order. At this point, you can use Polik-Hellman. You can sort of write part of the implementation yourself, so you don't have to find and factor the group order as sort of step one. If you do that, you can solve this in a few milliseconds, well under a second easily. I think my solve takes like maybe 100 milliseconds. You can plug this into a calculator and it will take maybe a few seconds or a few minutes, but it's possible to do much faster than that. And yep, that's all I have.
Okay, great. Thank you, Nikhil. And again, if you have any questions, feel free to ask them in general or Q&A. So now we will be moving on to a few challenges that Pete wrote. So Pete, take it away.
Yeah, can you hear me?
Yeah.
Okay. Yeah, so I'm mainly going to be doing Q&A, but Pony Maps is a bit encoding challenge, and I just wanted to mention that I made a mistake in the challenge. You can see in the picture below, I used the parameter beta twice instead of b. So your solve for Pony Maps would require a 16-bit brute force. In the picture at the bottom are the coordinates plotted out for the challenge. Do I have any questions on this one? Okay, sounds good. There it is. Okay. Yes, Too Fancy was a TCL bytecode reverse engineering challenge. I worked at a company that used TCL, so I decided to share that pain with all of you guys. So the reverse engineering is a 37 by 37 matrix multiplication problem, though I fill in the matrix in reverse diagonal order. So if you look up the lazy caterer sequence, that is how I derive the order to fill in that matrix. Yes. Any So the intended there is manual reversing with this tool TBC load. And then, yeah. Any questions on this one? Okay, sounds good. Okay, so Lost Canary was a reverse engineering challenge where one of the stations had a vulnerable stack canary and the rest were safe. In the security class at Illinois, they discuss non-randomized fixed stack canaries. So I decided to make a challenge where all the stations are safe with a fixed value, except for one of the stations. So once you locate the station with a Ghidra or Binja or IDA script, you can then use the buffer overflow combined with the scanf leak. The scanf leak, the printf leak, lets you leak a libc address. Another solution I didn't see a lot of people do was you could patch out the sleep and just brute force all stations and see which one crashes when provided an input. Yeah, I think that's probably a cheese to the challenge, though I'm not sure anyone did that. Any questions on this one? Okay. And then the last challenge is a MIPS buffer overflow challenge. So to exploit this, there's two passes. The first pass, or just a little bit of background about MIPS. MIPS restores registers from the stack after a function call. So you can overflow such that you change the saved registers, but you don't change the return address. So in the first pass, you'll do that. And then in the second pass, the control flow integrity check is now different based on your saved registers. So now you can jump into whatever branch you want to hit, which in this case is that system branch, which lets you execute code. Any questions on that? Okay. Thanks, everyone.
Thank you, Pete. And again, thank you to all of the challenge authors who wrote challenges for UIUCTF. Again, if you have any questions, you want to discuss write-ups, this sort of thing, ask in Discord. Again, a huge shout out to all of our sponsors, without which UIUCTF would not be possible. And again, I want to remind everyone we have a huge write-up pool this year. So get those write-ups in. Challenges big and small. The only caveat is challenges that are suites. So that's Goose Chase, Pony Pass, and the two OSINT suites. Those are challenges per suite and not per challenge. But again, syscalls is not a suite. Yeah. So thank you all so much, and we hope to see you next year. If you haven't already, fill out the feedback form. Vote for us on CTF time, and yeah, we're looking forward to seeing your write-ups.